At 12:01 a.m. Beijing time on January 1st, 2026, the world's technology supply chain fundamentally changed. There was no announcement, no press conference, no warning. Simply a new regulation posted on an obscure Chinese government website that would reshape global industry. Effective immediately, only state-approved enterprises with annual production capacity exceeding 80 tons could export refined silver from the People's Republic of China. For the hundreds of smaller exporters who had supplied the world's technology companies for decades, it was an immediate death sentence. For the global economy, it was the beginning of a supply shock that would redefine manufacturing in the 21st century. The regulation appeared mundane, buried in bureaucratic language about optimizing resource allocation and strengthening strategic material management. But those who understood China's role in global silver markets immediately recognized its significance. China did not just participate in the silver trade. It dominated the refinement and processing that transformed raw ore into the high-purity metal essential for modern technology. 40% of the world's refined silver flowed through Chinese facilities. More critically, Chinese companies had perfected the ultra-high purity processes required for semiconductor manufacturing, solar panel production, and advanced electronics. This wasn't just a trade restriction. It was a chokehold on the arteries of global technology. The timing was no accident. For months, tensions between Washington and Beijing had escalated beyond trade wars into technology warfare. Export controls on semiconductors, restrictions on rare earth elements, and competing industrial policies had created a new form of conflict, one fought not with missiles, but with supply chains. Silver represented China's unexpected leverage in this struggle. Unlike oil, which could be sourced from multiple regions, or even rare earths where alternative deposits existed, the infrastructure for high-purity silver refinement was concentrated in a handful of Chinese facilities. Decades of investment, expertise, and process optimization couldn't be replicated overnight. In Seoul, Samsung's emergency meeting convened at 6 a.m. local time. The company's chief procurement officer delivered the stark assessment. Their silver inventory would last 7 weeks at current production rates. After that, smartphone manufacturing would slow, tablet production would halt, and their newest semiconductor fabrication facility would face critical shortages. The numbers were staggering. Each smartphone required small amounts of silver, but Samsung produced over 300 million units annually. Their semiconductor operations consumed silver in photovoltaic cells, conductive pastes, and thermal management systems. Alternative suppliers existed in Japan and Mexico, but they lacked the capacity to replace Chinese supply. More troubling, they couldn't match the purity levels Samsung's advanced processes required. Across the technology sector, similar crisis meetings unfolded. Apple's Tim Cook canceled his New Year celebrations to coordinate response strategies. Tesla's engineering teams calculated how long their silver supplies would last for electric motor production. Microsoft faced shortages for server manufacturing. Every major technology company suddenly confronted the same reality. Their entire business model depended on a metal they had taken for granted, now controlled by a geopolitical rival. The interdependence that globalization created had become a vulnerability. But China's restriction went beyond simple export controls. The requirement for 80-ton annual capacity effectively limited exports to massive state-owned enterprises. These companies, directly controlled by Beijing, could allocate supply based on political priorities rather than market prices. Countries and companies that aligned with Chinese interests might receive favorable treatment. Those that didn't would face shortages regardless of their willingness to pay. Silver had been weaponized, transformed from an industrial commodity into an instrument of state power. The immediate market reaction was predictable, yet devastating. Silver prices in Shanghai surged 15% within hours of the announcement, triggering circuit breakers. London markets opened to chaos as traders struggled to price physical delivery against paper contracts. The COMEX in New York saw unprecedented volume, as industrial users rushed to secure any available supply. But the real story wasn't in futures markets. It was in the physical market where actual silver changed hands. Premiums for immediate delivery reached 25% above spot prices. Refiners reported being booked solid for months. The paper price of silver might show volatility, but the physical reality was stark. There simply was not enough high-purity silver available outside China to meet global demand. The solar industry faced immediate crisis. Photovoltaic cells required silver paste for electrical connections, consuming over 100 million ounces annually. Chinese solar manufacturers, protected by their government's export controls, suddenly held massive competitive advantages. European and American solar companies watched helplessly as their production costs soared, while Chinese competitors maintained stable supplies. The green energy transition, already dependent on Chinese manufacturing, now faced a new bottleneck. Climate goals collided with geopolitical reality. In Silicon Valley, the implications rippled through every boardroom. Data centers, the backbone of the digital economy, required enormous amounts of silver for electrical systems and cooling infrastructure. Each new artificial intelligence training cluster consumed silver in quantities that would have seemed fantastic just years earlier. The AI revolution, premised on ever larger computational systems, suddenly faced physical constraints. Companies that had planned massive expansions reconsidered. The digital future had a distinctly metallic bottleneck. But the challenge went beyond simple supply and demand. China's silver refinement infrastructure represented decades of accumulated expertise. The processes for achieving a 99.99999% purity, essential for advanced semiconductors, involved proprietary techniques that Chinese companies had perfected through trial and error. Temperature controls, chemical processes, and contamination prevention required knowledge that couldn't be simply purchased or replicated. Western companies attempting to build alternative refinement capacity discovered that equipment was one thing, expertise was another entirely. The secondary effects cascaded through supply chains. Electronic component manufacturers, dependent on silver for contacts and connections, began rationing production. Automotive companies, increasingly reliant on electronics, faced their own shortages. Medical device manufacturers competed with consumer electronics for limited supplies. Every industry that had digitized now discovered their vulnerability to silver availability. The Fourth Industrial Revolution had an Achilles heel, and China had found it. Financial markets struggled to price these new realities. Technology stocks, priced for growth, suddenly faced supply constraints that limited expansion. The Nasdaq fell 8% in 3 days as investors recalculated valuations based on silver availability rather than demand projections. But the selling was orderly compared to the panic in physical markets. Stories emerged of companies sending private jets to secure small quantities of silver from any available source. Mexican mines reported attempted theft of refined silver. Indian dealers saw unprecedented demand from technology companies desperate for any supply. The geopolitical implications extended far beyond commercial disruption. NATO defense contractors discovered their advanced weapon systems required Chinese refined silver for critical components. The F-35 fighter program, already plagued by supply chain complexity, faced new vulnerabilities. Missile guidance systems, satellite communications, and radar arrays all depended on high-purity silver components. Military planners, who had war-gamed various scenarios, hadn't considered that their advanced weapons might be disabled not by enemy action but by supply chain manipulation. China's strategy revealed careful planning. The 80-ton threshold wasn't arbitrary. It precisely excluded every independent refiner while maintaining the fiction of market access. The timing, during New Year holidays when Western governments were minimally staffed, prevented immediate coordinated response. Most cleverly, the regulation was framed as environmental protection and resource conservation, making international challenge through trade organizations difficult. China had learned from watching Western sanctions on Russia. Economic weapons were most effective when they appeared defensive rather than aggressive. The scramble for alternative supplies revealed the depth of the crisis. Peru and Mexico, the world's largest silver miners, couldn't simply increase production. Mining was a years-long process, and most output was already committed under long-term contracts. More critically, they lacked refinement capacity for technology-grade silver. Raw ore was abundant. The ability to transform it into usable metal was scarce. Building new refinement facilities would take years and billions in investment. Technology companies needed solutions measured in weeks, not years. In an extraordinary meeting, the CEOs of Apple, Samsung, Tesla, and other technology giants formed an unprecedented alliance. Competition was suspended in the face of existential threat. They pooled resources to fund crash programs for alternative refinement capacity. Former rivals shared inventory data and coordinated procurement strategies. But even combined, their efforts seemed inadequate ag scale of the challenge. China had spent decades building its silver refinement infrastructure. Replicating it would take similar timeframes, even with unlimited resources. The human impact began appearing in unexpected ways. Smartphone prices increased 20% as manufacturers passed through silver costs. Electric vehicle production slowed, delaying deliveries and increasing prices. Solar panel installations, crucial for energy transition, became economically unviable in many markets. The digital divide, already significant, widened as technology became more expensive. China's silver weapon had achieved something remarkable. It had made technological progress itself contingent on political alignment. Inside China, the strategy revealed broader ambitions. State media framed the export controls as protecting national resources from Western exploitation. Social media campaigns emphasized China's right to manage its own industrial policy. But privately, Chinese technology companies received clear messages. Silver would be available for domestic production and friendly nations. The goal wasn't to stop technological progress, but to ensure it flowed through Beijing. Companies wanting access to silver would need to accept Chinese partnerships, technology transfer, and political alignment. The desperation in Western capitals was palpable, Emergency meetings at the White House, 10 Downing Street, and the Élysée Palace sought solutions to a problem they had never anticipated. Strategic reserves existed for oil, gas, even medical supplies, but not for silver. The Defense Production Act could compel domestic manufacturing, but couldn't create refinement capacity that didn't exist. Diplomatic overtures to China met with polite stonewalling. Beijing had found leverage that sanctions couldn't counter and military might couldn't overcome. Alternative technologies offered limited hope. Researchers rushed to develop silver substitutes for various applications. Graphene showed promise for some electrical uses. Aluminum could replace silver in certain connections. But these alternatives involved trade-offs in performance, cost, or manufacturability. More fundamentally, retooling entire industries around new materials would take years. The installed base of manufacturing equipment, designed for silver-based processes, couldn't be easily modified. The sunk costs in existing technology created massive inertia against change. The market dynamics created unusual distortions. Paper silver traded on financial exchanges diverged dramatically from physical prices. The London Bullion Market Association reported physical premiums reaching 30% above futures prices, unprecedented in modern commodity markets. But even at these prices, physical silver for technology uses remained scarce. Financial silver held in ETFs and allocated accounts couldn't easily be converted to the high purity forms technology required. The monetary and industrial silver markets, long interconnected, began separating. 3 weeks into the crisis, the first production shutdowns began. A semiconductor fabrication plant in Taiwan, unable to secure silver for critical processes, halted operations. The ripple effects were immediate. Chip shortages, barely recovered from previous disruptions, returned with vengeance. Automobile manufacturers canceled shifts. Consumer electronics faced allocation shortages. The just-in-time global economy, optimized for efficiency, proved catastrophically vulnerable to single-point failures. But the crisis also revealed hidden dependencies. Medical devices, from MRI machines to surgical instruments, required silver components. Aerospace manufacturers discovered that next-generation aircraft designs depended on silver-based materials for electromagnetic shielding. Telecommunications infrastructure, expanding rapidly for 5G deployment, consumed vast quantities of silver for antennas and connections. Every aspect of modern life, it seemed, had some dependency on refined silver, and therefore on Chinese cooperation. The price signal worked exactly as economics textbooks suggested, but the results were catastrophic rather than efficient. Silver mining companies saw stock prices soar as investors anticipated bonanza profits. But increased mining couldn't solve refinement bottlenecks. Raw ore piled up at facilities lacking capacity to process it. The few non-Chinese refiners operated at maximum capacity, but their output satisfied only a fraction of demand. Price increases that should have balanced supply and demand instead revealed that supply could not respond to price signals when infrastructure was concentrated in hostile hands. Intelligence agencies reported unusual activities around Chinese silver facilities. Production appeared to continue at normal rates, but exports had slowed to a trickle. Satellite imagery suggested new storage facilities under construction. The implications were disturbing. China wasn't reducing silver production, it was stockpiling. Whether for future industrial use, price manipulation, or geopolitical leverage remained unclear, but the message was unmistakable. China intended to maintain control over this critical resource for the foreseeable future. Corporate responses varied from innovative to desperate. Tesla announced a crash program to develop silver-free electric motors, promising results within 18 months. Apple explored radical design changes to reduce silver content in devices. Samsung partnered with Mexican mining companies to develop new refinement capacity. But these efforts, even if successful, wouldn't bear fruit for years. In the immediate term, companies faced stark choices: reduce production, redesign products, or accept Chinese terms for silver access. The diplomatic maneuvering intensified. Japan, entirely dependent on imported silver, led efforts to challenge Chinese restrictions through international trade bodies. The European Union threatened retaliation through its own export controls. The United States considered invoking defense provisions to restrict technology exports to China. But these responses seemed hollow against China's material advantage. Trade wars were symmetric when both sides had comparable leverage. China's silver monopoly created fundamental asymmetry. 6 weeks into the crisis, the first major Western company broke ranks. A European solar manufacturer, facing bankruptcy without silver supplies, agreed to move production to China in exchange for guaranteed access. The decision triggered fierce criticism, but also understanding. When survival was at stake, principles became luxuries. Other companies watched carefully, calculating how long they could resist before making similar compromises. China's strategy was working, not through conquest, but through commercial pressure that left companies no alternative. The technological implications extended beyond immediate shortages. Research and development programs, dependent on specialized materials, faced delays or cancellation. Universities reported that advanced materials research had become impossible without Chinese cooperation. The innovation ecosystem, built on free flow of materials and ideas, confronted new barriers. Young engineers and scientists reconsidered career paths, wondering if their fields would exist without Chinese material supplies. The future itself seemed rationed. Financial markets developed new instruments to handle the crisis. Silver futures, specific to technology-grade metal, emerged, trading at substantial premiums to traditional silver contracts. Companies created complex hedging strategies to manage supply risk. Insurance markets developed policies covering supply chain disruption from geopolitical actions. But these financial innovations couldn't create physical silver where none existed. They merely redistributed risk without addressing underlying shortages. The social impact varied by region. In Asia, where technology manufacturing concentrated, unemployment rose as factories reduced production. In America and Europe, consumers faced higher prices and product shortages. The promise of ever cheaper, ever better technology, a cornerstone of modern life, suddenly seemed historical rather than inevitable. Parents couldn't buy laptops for remote learning children. Hospitals deferred equipment upgrades. The digital transformation that COVID had accelerated now faced physical constraints. China's internal dynamics revealed careful orchestration. State-owned enterprises received priority access to silver supplies. Private companies faced allocation based on their perceived strategic value and political reliability. Foreign companies operating in China discovered that silver access depended on technology transfer agreements and acceptance of Chinese partners. The Communist Party had transformed an industrial metal into an instrument of state control more effective than any surveillance system. The search for solutions spawned numerous initiatives. Mining companies announced plans for new refinement facilities, though construction would take years. Governments funded research into alternative materials with urgency, typically reserved for wartime efforts. Recycling programs expanded dramatically, though recovered silver rarely met purity requirements for advanced applications. Each partial solution highlighted how comprehensively China had captured a critical node in global supply chains. Environmental consequences added another dimension to the crisis. The push to develop non-Chinese refinement capacity often meant accepting lower environmental standards to accelerate construction. Countries that had banned certain mining practices reconsidered when faced with technology shortages. The green transition, dependent on silver for solar panels and electric vehicles, faced compromise with environmental protection. China's export controls had created a devil's bargain between technological progress and ecological preservation. By March 2026, new equilibriums began emerging. Some Western companies accepted Chinese partnerships, trading independence for supply access. Others dramatically reduced production, focusing on high-margin products that could absorb silver costs. A few pioneered alternative technologies, accepting performance penalties for supply security, but all faced a fundamentally changed landscape where a single country controlled a critical input to technological civilization. The military implications drove defense planners to radical reconsiderations. Weapon systems designed assuming reliable component supplies needed redesign for autarkic production. Strategic stockpiles, previously focused on oil and rare materials, expanded to include refined silver. War games incorporated supply chain warfare as a primary domain of conflict. The revolution in military affairs had assumed technological superiority. China's silver controls demonstrated that technology itself could be held hostage. Academic analysis revealed the depth of strategic miscalculation. Decades of globalization had proceeded on the assumption that economic interdependence prevented conflict. Instead, interdependence had created vulnerabilities that enabled new forms of coercion. Efficiency optimization had eliminated redundancy that might have provided resilience. The global economy resembled a machine with no spare parts, functional when operating, but catastrophic when any component failed. Corporate earnings calls became confessionals of strategic failure. CEOs, who had celebrated supply chain efficiency, now explained why their companies couldn't produce products. Stock prices reflected new realities where access to materials mattered more than market demand. The technology sector, accustomed to disrupting others, found itself disrupted by geology and geopolitics. Innovation meant nothing without the physical materials to implement ideas. The cultural impact was profound. The assumption of inevitable technological progress, embedded in Western consciousness, faced material contradiction. Science fiction had imagined many futures, but rarely one where progress stopped for lack of a common metal. Children who had grown up expecting ever more powerful devices learned about scarcity and trade-offs. The digital native generation discovered that their virtual world rested on very physical foundations, controlled by geopolitical rivals. International relations shifted to accommodate new realities. Countries with silver deposits found themselves courted like oil producers in previous eras. Mexico and Peru gained leverage they had never previously enjoyed. Mongolia, with undeveloped silver resources, became a strategic prize. The new great game focused not on territory or ideology, but on access to the materials that enabled modern life. Diplomacy adapted to a world where industrial metals mattered more than military might. By mid-2026, patterns had solidified into new structures. China's silver weapon had achieved its objectives without firing a shot. Western technology companies operated under constraints that would have seemed impossible just months earlier. The unipolar moment of American technological dominance had ended, replaced by a world where critical materials created hard limits on power projection. The future would be negotiated not in trade agreements or security treaties, but in allocation of the metals that made modernity possible. The lessons were stark and undeniable. Efficiency and resilience existed in fundamental tension. Globalization's benefits came with vulnerabilities that rivals could exploit. Technology leadership required not just innovation, but secure access to physical inputs. The digital economy ultimately rested on very analog foundations. And perhaps, most importantly, assumptions about rational economic actors failed when states prioritized power over profit. The immediate crisis would eventually ease as new refinement capacity came online and alternative technologies developed. But the world had fundamentally changed. The naive optimism about global integration had died in the face of weaponized interdependence. Future supply chains would be designed for security rather than efficiency. Technology development would consider material access as carefully as market demand. And silver, the metal that had served as money for millennia, had reminded humanity that physical reality ultimately constrained even the most virtual ambitions. The great technology companies that had seemed invincible discovered their mortality in the most mundane way possible. They ran out of a metal they needed to make their products. The governments that had projected power globally found themselves powerless against supply chain manipulation. The consumers who had taken technological progress for granted learned that it depended on geopolitical stability and material access. And China, through patient preparation and strategic timing, had demonstrated that in the 21st century, control over critical materials could be more powerful than any traditional weapon. The silver crisis of 2026 would be remembered not for its immediate disruptions, though those were severe, but for marking the end of an era. The age of naive globalization, where economic logic trumped strategic consideration, had conclusively ended. The new era would be characterized by secured supply chains, material autarky, and recognition that technological leadership required not just innovation, but guaranteed access to the physical inputs that made innovation possible. In this new world, a common metal had proven more strategic than the most advanced semiconductors, because without the metal, the semiconductors couldn't exist. The story continued to unfold, measured in factory closures and diplomatic initiatives, in research breakthroughs and corporate capitulations. But the fundamental lesson had been learned. In an interconnected world, the greatest vulnerabilities lay in the connections themselves. China had found one such vulnerability and exploited it masterfully. The question facing everyone else was simple but profound. In a world of weaponized interdependence, how could technological civilization be maintained without accepting unacceptable dependencies? The answer to that question would shape the remainder of the 21st century.